Well, in this video, we'll speak about the concept of degrees of freedom. Degrees of freedom defines the dimensionality you need to describe the pose of the robot. Depending on the shape or the type of robot, pose have a slightly different meaning. If you are speaking about a box-like robot, pose exactly that, the position and orientation of the robot. But if we are talking about a robotic arm, an industrial manipulator, we refer to the pose of the end effector. Let's say as if it were my hand, where it is and where it is looking at. Okay. For example, if we get this little robot, Themia, you already know, this robot can move on a plane. Okay, so you could think we only need 2 dimensions, 2 parameters to define its position, and so it has 2 degrees of freedom. Okay, to see it's here or it's there. But as the pose of the robot is position plus orientation, we need to know where the robot is looking at. And so we need a third dimension, a third parameter, which could be the axis, the angle around this axis. So we have not only the position, but also where the robot is looking at. In the case of link-based robots, specifically industrial manipulators, that is where it is commonly applied, this idea of degrees of freedom, we usually get degrees of freedom in each of the joints that put together different links of the robot. Imagine these are 2 links. If they can only rotate around the axis orthogonal to them, we have only 1 degree of freedom. If we could do more complex movements, we could have more 2 or 3 degrees of freedom. And usually the number of the degrees of freedom of the robot, you get it just adding up the degrees of freedom in each joint. Related specifically to this kind of robot, industrial robotic manipulators, there is another interesting concept, that of workplace. The workplace is the set of points in a space that the end effector of the robot can reach. Again, imagine this is a robotic manipulator and my hand is the end effector. It's where my hand can reach in space. Although the real shape is much more complex, you can imagine right now like a sphere around my shoulder, although the inner of the surface is much more complex, as I said. Well, it is demonstrated that an industrial manipulator, a robot with 6 degrees of freedom, can reach every single point in the workspace. If you have a robot with less than 6 degrees of freedom, you cannot reach every point in the workspace. But on the contrary, if you have more than 6 degrees of freedom, of course, you can arrive to every single point in the workspace and you gain maneuverability, but at the expense of more complexity and more cost. All in all, usually industrial robots have more than 6 degrees of freedom just to get that maneuverability. So as you can see, the degrees of freedom of a robot is a very important trait that confer them reach and maneuverability, and it's an important parameter, an important data for the study of kinematics. We won't see more about this concept of degrees of freedom, but if you're serious on robotics and mechanics, and specifically kinematics, probably you will need to deep dive on this idea.